Okay. Good evening, class. Good evening again. Okay. So we can check who is present. Philip, Emmanuel. Okay. So the unit of competency is apply electrical principles, and today we are going to the unit of the session title today will be units of electrical quantities, and the learning outcomes is displayed there. So by the end of the session you should be able to identify electrical quantities. 2. State the SI units of electrical quantities. 3. Perform calculation on electrical quantities. Are we together, class? Are we together? Okay, thank you. Okay, let me move faster. Okay, let's start with charge. What do you understand by charge, class? Any attempt? Okay, so the unit of charge is coulombs, whereby 1 coulomb is 1 ampere second. 1 coulomb is given by 6.24 times 10 raised to power 18 electrons. 1 coulomb is defined as the quantity of electricity which flows past a given point in an electric circuit when a current of 1 ampere is maintained for 1 second. We know 1 coulomb is given by the equation Q is equals to IT, where I is the current in amperes and T is the time in seconds. Let's look at the problem. You are given a current of 5 amperes which flows for a time of 2 minutes, and you are told to determine the quantity of electricity. So we apply the formula. Q is equals to IT. We have current is 5 amperes and time is 2 minutes, so we convert to seconds, and we apply the formula as shown on the display, and finally the product is 600 coulombs, which is the quantity of electricity transferred. Now let's look at another quantity, which is force. Unit of force is newtons. 1 newton is 1 kilogram meter per second squared. Newton is a force which, when applied to a mass of 1 kilogram, gives it an acceleration of 1 meter per second squared. Force is given by the product of mass and acceleration, and we have mass in kilograms and acceleration is normally in meter per second squared. Whereas in gravitational force we have the acceleration given by 9.81 meter per second. Now class, let's approach this problem whereby we have a force acting vertically downwards on a mass of 200 grams, and we are told to find what? The force. So what's the attempt? We apply the formula. Force is equals to mass, you multiply by acceleration. In this case the acceleration is what? This is the gravity. So we do the conversion of mass into kilograms, and we have the acceleration as what? Class 9.81 meter per second squared. Yes. So when we do the product, that is the product of mass and acceleration, we have 1.962 newtons. Okay, let's look another quantity, which is work. So the unit of work or energy is the joule. 1 joule is 1 Newton meter. The joule is defined as the work done or energy transferred when a force of 1 Newton is exerted through a distance of 1 meter in the direction of force. We know the formula of work is given by the product of force in newtons and S, which is in distance meters. So energy is the capacity of doing work. Let's look at power. The unit of power is the watts. 1 watt is a joule per second. Power is defined as the rate of doing work or transferring energy. We know the formula of power is given by work over time, as in W over T, as shown in the screen, whereby W is work or energy transferred in joules and T is time in seconds. So when we talk of work, it is the product of power. It's the product of power and time. So class, are we together? Hello? Okay. What have we say is power? Who can give it an attempt? Yes. Yeah, we have said the unit of power is watts. Thank you for that, Emmanuel. Now let's look at this problem. We have a portable machine requires a force of 200 newtons to move, and we are told to calculate work done if the machine is to move 20 meters. And also we are told to calculate power it utilizes if the movement takes 25 seconds. So first of all, we approach the problem of work. So we apply the formula. Work is given by the product of what? Force and distance. And we have force as 200 newtons, and we have our distance as what? 20 meters. So when we do the product, we have 400 newton meter. So when we do the conversion, it is the same as 4 kilojoules. For power, we do what? We said work over time. Already we have gotten work as 4,000 newton meters, so we divide by what? 25 seconds, and we have 160 watts. Class, any question up to there concerning work? Okay, thank you for that. Hope it's understood. Now, here is an assignment. Yes, Philip, you wanted to say something? Okay, now let's continue. So this is assignment. Oh, sorry for that. I see you are back. Thank you. We are continuing. This is the assignment for the... Okay. The assignment is displayed. A mass of 5,000 grams is accelerated at 2 meters per second squared by a force. You are told to determine the force needed. So that is the assignment for the class. Have you written it down? Okay. So this is the assignment we shall look at during the next lesson. Now these are your reference material for this unit. So one is META, that is basic electrical engineering, and 2 we have John Bird, electrical and electronic principles and technology. So class, thank you for participating in this lesson.